In this video, we're going to be looking at some more tricky algebraic proof. So we're going to start off by talking about two more sort of basics that we need to know for these. So the first is every three numbers, one of them must be a multiple of 3. If you have A, B, and C, one of these, A, B, or C, has to be a multiple of 3. And the second basic that we're going to look at is when we have this thing n bracket n plus 1. Now, if we just look at this thing here now, if we put in the value 1 to it, which is an odd, we're going to have 1 multiplied by 2. It's going to give us 2. Actually put in a value of n equals 2 to this, we're going to have 2 multiplied by 2 plus 1, which is 3, which is 6. Hopefully, you're noticing that these values are both even. Now, this is going to come from the fact that this n and this n plus 1 are consecutive numbers. So if we choose n to be odd, n plus 1 must be even. Alternatively, if n is even, n plus 1 must be odd because it's a number after. So we're going to end up with a situation where we have an odd times an even, which always gives us an even. So let's look at a couple of examples. Show you that an odd number squared is 1 more than a multiple of 8. So we're going to remember from our last video that we write our odds as 2n plus 1. So we need to show that this 2n plus 1, when we square it, and we're squaring the whole thing, hence why we got brackets, we're going to end up with a multiple of 8. So we're going to square this. We're going to use our grid method to show this. Two n plus 1, 2n plus 1. So 2n plus times 2n is 4n squared, 2n plus 1. So expanding this is going to give us 4n squared plus 2n plus 2n plus 1. And we can simplify this. Now, the trick with pretty much most of the questions with algebraic proof is to factorise. Now, I want to show it's 1 more, so I'm going to leave this plus 1 out of the factorising. And I'm going to factorise this thing. So we're going to have 4n, n plus 1. So hopefully you can see this is what we're talking about before. So we can say as n multiplied by n plus 1 is consecutive numbers being multiplied, this is the product, meaning multiplication, of an odd and even, so it is even. Now, how does this help us when we're talking about wanting it to be multiple of 8? Well, if we've got 4, because we have this 4 out the front, multiplied by an even number, this will be a multiple of 8. And as we've got this plus 1 on the outside, it's going to be 1 more. There's one more example I want to talk about. So we have if 2 to the power of x take away 1 is prime, show that 2 to the x plus 1 is a multiple of 3. Now, the best way I think to answer this question is by listing it out. So 2 to the x take away 1 is prime. They tell us this in the question. Now the number after this, will it be 1 more than this? So it would just be 2 to the power of x. Now because of prime factor decomposition, because we'll just say prime factors, 2 is the only factor, i.e. not 3, so not a multiple of 3. Well, how does that help? Well, we know from our first slide that with 3 consecutive numbers, one of them has to be a multiple of 3. So as the previous 2 numbers, were not multiples, three, 2 to the x plus 1 must be.